Hello guys, welcome to the Civil Engineering YouTube channel. Please subscribe our channel for more civil engineering updates. So today our topic is about what is ductile and what is brittle material and what is the difference between these two material and what material should we use in our construction projects. Right, ductile are either brittle. So I will show it by a diagram, and I will show here that what material we should use in our construction, right? And what are the advantages and disadvantages of these two material. So ductile material is that material which goes into a high uh, plastic deformation stage, right? While and it can absorb more energy. This is the one, and this is the second. It can absorb more energy, right? I'm just defining this material, and then I will explain it by a stress strain diagram. While the brittle material are those which have less or no plastic deformation stage. Plastic deformation, right? No or very less plastic deformation stage in this material, brittle. And the second is it absorbs more energy, while it doesn't absorb high energy, less energy I can say. It stores very less energy, right? So this was the definition of ductile material and brittle material. Now I will explain it by a stress strain diagram. Actually it shows clearly that which material is to be used in construction engineering projects, right? So I will show it by stress strain diagram. This is the x-axis and y-axis. On y-axis I'm showing it the stress, because it is dependent, and the x-axis is the strain. It is independent quantity. So for example, taking a material like I'm taking this material, I don't know about this material, but this is ductile and brittle, and I will show it by stress strain diagram. For example, this is a steel bar, grade 60 or grade 40, and I'm going to elongate it by pushing our tensile forces, right? Tensile forces, pushing it another way. I'm acting tensile forces on this steel bar. This is a steel bar. I take an example of this. So what will happen actually when I'm applying a force stress? So the strain will also develop in this material. So the graph will go like this, right? This will follow the stress. I'm going to apply the stress. It will change and increase. Strain will increase in the same way as the stress. So a limit will reach that. First of all, I'm going to explain ductile material, right? So this is a ductile material graph. A ductile material, I can write it here, ductile material. So when the load is applying and the strain is also coming at this material, so one stage will reach that the proportion limit in which the stress is directly proportional to the strain, it will not be, it will occur to its extreme point, and this point. After that, it will start another point. We call it the yield point here, in which the stress strain proportionality changes from the elastic limit to the plastic. We call as the yield point. So this is the yield point, while this is the proportional point also. This is the proportional point, this is the yield point. And now after again the stressing of bars, it will show again some deformation, and it will follow a path like this, and then it will go fracture down and coming into the lowest point, right? So at this point where it shows the maximum stress, it means it shows the ultimate strength of this material. This point shows the ultimate strength of this material. We call it ultimate, right? So I'm writing it here, ultimate strength of this material, which I suppose is the steel bar, right? And this area we call is the strain hardening, and this area after onwards we call is necking, and which the area and which the dimension of the steel bar is very less as compared to the stress applied. So this we call is necking. So coming to the start point, that after when the load is applied, the stress and strain follow a straight line proportional, then it changes into the proportionality, changes into the yield point, and then again after applying the load it will go on and the ultimate stage will reach, and after that it will break and fracture and going down. So this was the graph of the ductile material. It shows that it can absorb more energy. We can go and the load is applied and it can go into more deformation, right? This is a strain. It means it can go into a more deformation stage, because this is the elastic stage, right? Elastic in which I've applied the load. After removing the load, it will come to its own position. So it's the elastic behavior up to this point. While after this point into this, we call this plastic region. So it shows more plasticity, more plastic deformation in this ductile material, right? While in case of brittle, that energy absorbed, or we can say the stage of plastic is very less up to this point, maybe, or very less. So we call it the brittle material, because it doesn't show any plastic deformation more as compared to the ductile material, and it doesn't show any absorption of energy. It shows, this is the ductile material, so it shows there's a lot of energy has been stored. This shows area under the curve, right? So it shows a lot of energy has been stored in this material. So that's why we call it ductile material. While in case of the brittle material, for example, I'm against drawing stress and strain diagram. This is stress and this is strain. So in case of the brittle material, if I applied the load, like for example, this is a marker. Consider it is a marker, not a steel bar. So if I apply the load, it will go. But at a certain stage, at this stage, what it show? Look at the marker head. It will show break. Why? It will break out into two parts. Why? Go into this like this. Up to this, it will show a linear proportion graph between stress and strain, and after this it will directly be fractured or be broken into two parts. So this is the only point. This up to this, we can see this is a proportionality. Maybe the stress is directly proportional to strain, while and up to onwards it will not show any deformation, strong deformation, but it will go into the two parts. It will broken into two parts, brittle material. So this is the property of the brittle material, that it doesn't absorb any energy. So this is absorption of energy under the curve. So it will absorb less energy absorbed, right? And this is the brittle material we see. When in case of the ductile material, huge amount of energy disturbed, and there is this elastic limit, we can say, in which the stress is equal to strain, and if remove the load, it will come back to its own position. This is elastic limit. While there is no plastic deformation, or really less plastic deformation, we call it plastic deformation, and very less amount of energy is stored being in this material. So we classify it as this is a brittle material, right? So I'm giving some extra information about the ductile and brittle material, like for example, I'm considering the grade like the grade 60 bar, grade 60 bar, and grade 40 bar, right? These are most commonly used in engineering projects. So grade 60 has more strength because it is more carbon. The more carbon elements, the more well strength, more carbon, but it is less ductile. Less ductile material. Okay, so the 40, it is high. This was more strength. It is less strength. It is less strength. It is less due to less carbon, and due to less carbon, when less carbon is used, it will have more ductile, right? More ductile. So it means the carbon content is inversely proportional to the ductility. If the more is the carbon content, the less will be the ductility. Grade 60 is more carbon, so it is less ductility. It is less carbon, so it is more ductility, and also the carbon is directly proportional to the strength. It is more carbon, so it is more strength. It is less carbon, so it is less strength. So this was all about the ductile and brittle material, and we should focus on ductile material. We should use and ductile material in our engineering projects. Why? Because it can absorb and can show us that the material doesn't fail and before failing we can go out of the beam, because it will show ductile material, not a brittle, not it will not show the failing of the material instantaneously, but we will choose the ductile material so that it shows us the failure condition, and after failing we should go out of the room, while brittle material will not show any failure condition, but it would fail directly, and many accidental changes can be happen. So, and please subscribe our channel for more civil engineering videos, as we are uploading daily civil engineering updates, and thank you for watching.